Well, Matrix, welcome to Matrix Uploaded, grade 10s and 11s. I hope you're watching as well. Now, in this lesson, we're going to be focusing on calculus. It's really a matric topic, and grade 10s and 11s, you're not going to really know much about this at the moment, but why not look at the history a little bit? So grade 10s, 11s, it might be useful to see what is coming in the years to come. Okay, calculus is an incredible mathematical tool. Okay, now let's just go into a little bit of history of calculus. It's really probably one of the greatest creations of human thought. It has become a powerful tool for solving important problems in the world of maths and science. The father of calculus is really Isaac Newton. He was one of the great mathematicians of the world. And as you know, those of you that do science as well, Isaac Newton was really a legend. It was during the 17th century that calculus was invented as a means of investigating problems involving motion. Okay, think about speed. What does that involve? Distance in relation to time. If I travel from here down to Cape Town in a motor car, what's happening? Distance and is being traversed, or you got distance, but you also have time. So it takes time and distance, and those are interconnected. And what is the relationship between distance and time? Speed. And calculus involves these sorts of relationships. Okay, the pioneers of calculus were the great mathematicians Newton, Leibniz and Cauchy. And I love the work of Newton. He's such an incredible man. He was such an incredible mathematician. Okay, so this grade 10s, I want you just to listen to a little bit of history here, grade 11s as well. And then if you want to, you can be quite courageous and go with me on a journey through what you would do in matric anyway. And modern day applications of calculus include such incredible things as the rate of growth of populations, predicting the outcome of chemical reactions, measuring instantaneous changes in electrical current. You can see there's just so many applications of this incredible field of study. Okay, and if you describe the behavior of atomic particles, look at this in medicine, guys, estimating tumor shrinkage in radiation therapy for those people that battle with cancer. Can you believe it, that calculus is a tool that can be used in the real world? Forecasting economic profits and losses, determining the spread of epidemics. Profits and losses, if you go into the share market investing money, calculus is a tool that can help you. All sorts of things. The impact of motor vehicle emissions on the ozone, on ozone depletion. You know, when they talk about global warming, calculus, global warming, can you believe it? But yeah, maybe is a warning that we must look after our environment. But all of these things, analyzing vibrations in mechanical systems, all of these things use calculus. There is so much that you can do with this wonderful topic. And matrics, get ready for all the main principles of calculus that we're going to explore. Now, let's start at the beginning. Grade 10s, I want you to watch this. Okay, you probably will be able to understand the parabola graph that I'm using, and you probably might understand FX notation. I know you grade 11s have done it. Now, FX notation, grade 10s, when your teachers do that at school, make sure you master that FX notation. Remember, if you look at this little diagram here, we've got a little parabola, x squared plus 1, that you will learn to draw at school. And then if we've got f of x, now fx really means the y value corresponding to a given x. So if you look at this, if I, for example, take 1, the f of 1, remember what this symbol means. The f of 1, grade 10s, is you simply replace all the x's with 1 and you get a corresponding y value of 2. So on your graph, what you have, and this is so important to realize, that you have a 1 for x and a y value of 2. Now, matrics, this is so important to you, especially in calculus. Remember that the 2 is really the f of 1. Okay, the f of 1 is the y value. This is such an important principle, so hold on to this. So grade 10s, the important thing for you is to understand how to work out f of 1. If I said to you, what is the f of 4? Well, what would you do there? You would replace the x's with 4, and that gives you 17. So that would be the y value corresponding to x is equal to 4. Okay, so that would be 4 and 17. Okay. All right, so be careful of that, people. That's so important. This is the F of 4. Okay, so this is the basics. So when we work out limits, let's just give you a basic idea of this. You can see what have I done as x approaches, as the x values approach, 1 from the left and right, your y values are approaching 2. Now that's an important principle, matrix that you need to be aware of. As the x's approach 1, the y values approaching 2. Okay, and we call that the limit as x approaches 1 of fx. But stay with us. We're going to continue with this in the next part of this lesson.